Welcome to a new episode of the Machine Learning Essentials series. I'm Seth Juarez. In prior videos, we've seen how Azure, and in particular Azure Machine Learning, is so well equipped to handle our ML workloads. Right from the tools and IDEs we need to the frameworks we're familiar with, through to deployment of models, everything is seamlessly provided in a single workspace. But is Azure ML the only way to do ML on Azure? What if your organization has made a big bet on another engine or has experts who want to leverage their choice of environment? Well, Azure is not at all opinionated and provides you with all the flexibility of choice. Machine learning on Azure can happen anywhere with an Azure SQL DB, Azure Synapse Analytics, or a very popular Apache Spark-based service on Azure called Azure Databricks. In this video, we'll take a look at why and how you can leverage Azure Databricks for ML. Now, some of you might be wondering about Apache Spark. For those of you who are not aware of Apache Spark, it is the most popular open source engine for distributed data processing. It leverages compute clusters scalable to hundreds or thousands of nodes to process large amounts of structured and unstructured data in an efficient way, making it a compelling choice for both big data processing for analytics and complex iterative processing associated with machine learning. Well, if you ask a data scientist to describe their typical tasks, you will notice that they spend about 70% or more of their time cleaning, curating, and processing data to make it ready and relevant for the subsequent modeling process. This is important to understand. If you're spending so much time dealing with data preprocessing, you might as well use an engine which provides you with the most comprehensive set of capabilities to do it in a scalable way. Today, Spark is the most popular and feature-rich engine to process any data at scale. Further, what is machine learning? Well, at its core, it's basically an iterative process to apply linear algebra and calculus-based equations on data to understand correlation, causality, and such. It's basically you're making a function with math, which means that there is a lot of data processing that is happening. And it could take advantage of sophisticated distributed processing. That is exactly what Spark brings to the table. Spark also offers a native ML library called MLlib, and its contributors collaborate in the OSS space to enable other popular frameworks like TensorFlow, PyTorch, scikit-learn to also execute in a scalable and distributed manner. Hopefully now you understand why there's such a big community for ML practitioners on Spark and such pace of innovation in the Spark space for ML. Bringing all of this innovation in Spark and extending its ability in a single unified service that provides the right processes and tools for ML is what Azure Databricks is all about. Azure Databricks is built by Databricks, who are the founders of Spark and contribute a bunch of code to the Apache Spark project. Azure Databricks uses Spark as its core, but builds even more performance optimizations and ML workflow streamlining with managed experiences for Delta Lake and ML Flow. These are some more projects that Databricks has also open sourced recently and are now growing exponentially. Another innovation Databricks brings to ML data preprocessing is Koalas. For those not aware of Koalas, it is a data processing library designed around the syntax of another very popular library called Pandas. Pandas is by far the most widely used Python library for data processing. It is extremely useful, but it has one shortcoming. It is designed for small amounts of data, or should we say it is designed to leverage only scale-up architecture. To overcome the single node execution of Pandas and enable a scale-out architecture for processing, data scientists and our data engineers would really need to rewrite the data processing in native Spark. Koalas eliminates the need to do that. You can use native Pandas syntax and still be able to scale out your data processing. This means data scientists and data engineers can now be more productive. All this comes natively as part of Azure Databricks. As we look at creating ML models in Azure Databricks, you will also notice that they've introduced the concept of ML projects. This ties deeply into the ML workflow process and integrates with ML Flow seamlessly. In addition to that, Azure Databricks offers a rich collaborative notebook experience with co-editing capabilities, review commenting functions, and GitHub integration. This means your data science teams can work seamlessly on projects and complement each other's skill sets. Azure Databricks not only makes the job of the data scientist easy, it also packs a serious punch in the underlying compute it provides. You can bring your choice of compute VMs as nodes for the cluster. It enables both CPU and GPU VMs, providing specialized Spark runtimes to help leverage the GPU distribution even more effectively to provide optimal ROI. Talking about ML in Azure Databricks cannot be complete if we do not mention ML Flow. ML Flow is a managed ML workflow experience in Azure Databricks. It has quickly become a very popular OSS ML workflow management tool. It has over 2 million downloads every month and has over 270 contributors. This is huge for any OSS project. ML Flow in Azure Databricks provides an effective way to track your experiments, provision reproducibility for your runs, package your models and environments, manage these packages in a registry, and deliver end-to-end ML experience for Spark enthusiasts. Microsoft is a core contributor to ML Flow and has built integration between ML Flow and Azure ML to allow data science teams to be able to centralize all their ML management in a single place, Azure ML. You can choose to set your ML Flow backend as Azure ML, enabling teams to continue to use ML Flow APIs but register all the artifacts in Azure ML. This is particularly useful when large teams want to collaborate using different engines in Azure, for example, Dask, Spark, SQL, whatever. All teams can use the tools and engines of their choice and still keep their work centralized. That is the flexibility of Azure. As we've seen throughout this episode, there is no reason for anyone wanting to use Apache Spark as their preferred ML environment to look any further than Azure Databricks. With built-in capabilities to distribute your ML processing and the backing of the latest in OSS innovation like Delta Engine and ML Flow, Azure Databricks is your one-stop shop for all things Spark on Azure. Hope you got a glimpse of some of these capabilities in this episode. Looking forward to seeing you in the next one.